All right, similar to this, we are going to have a topology and we are going to use DNS to resolve IP address, sorry, domain name into IP address. 3 routers, 2 PCs, sorry, 1 PC and 2 switches. And that PC is marked as DNS server. Actually, a router can also be a DNS server. Maybe the packet tracer router may not support the command to configure a DNS server. There's a command called IP DNS server. I think that the command is not supported in packet tracer. That's why they have kept a PC to act as a DNS server. I'm in page number 31 of our lab guide. Okay, so you don't need to refer to your lab guide now, just focus on the board only. I'm going to demonstrate and you're going to repeat similar lab later. Right. So a server to be my DNS server and one switch is enough. Okay, they have 2 switches because they want to do routing. Okay, I'll also take 2 switches and I'll keep one router to route traffic to 2 different LAN. And this is one LAN, this is another LAN. And here is the DNS server. I don't think there will be a port to connect. Yeah, there's no port to connect. Let me see how they connect. We can also add a port. Oh, they are connecting through a switch. No problem. So they have kept the DNS server on one of the local area network. It's okay. This is the topology they have. Okay, on router 2, left side is 10, 10, 10, 2. So this is router 2. I'll call it as router 2. And the IP address 10, 10, 10, 2/24. And for this DNS server, the IP address is 10, 10, 10, 10, 24. And the other side of router 2 is 10, 10, 22, I believe. Yeah, 10, 10, 22. /24. Which means this should be 10, 10, 10, router 3, I believe. And the IP address is 10, 10, 21. Am I right? Yeah, it's router 3, 10, 10, 21. And this will be router 1, 10, 10, 10, 1. All right. So this is our design. Similar only, but only the position is kept different. This is one local area network, you see. These are in same network 10, 10, 10. And these are in another network. So this is to show you that DNS works even in different network. Your DNS server may be in one network, but it can also work for another network. That's how the whole world is connected, you see. Yahoo is in one network, Facebook is in another network. But DNS resolves the whole world domain name into IP address. First is I would like to go and configure the DNS server. See how to configure DNS server in the simulator. You can use a Windows server as a DNS server. You can use a router as a DNS server. Here we have a simulated device as a DNS server. First, let us give IP address to this device, which is 10, 10, 10, 10. And the mask is 24 mask. The gateway is, you see the router's IP address is the gateway 10, 10, 10, 2. Next, what I would like to do is go to service and click on DNS. You see here? See, normal PC will not have. I have taken server. How did I take this server? By clicking this host here, and you see the third one. I dragged and dropped like this. All right. All right. Now I clicked on DNS and I turn on the before I turn on the DNS, let's give a name. If someone is typing router A, capital, from then the resolved address, this router A need to be resolved as 10, 10, 10, 1. Add. Okay, this can be lowercase or uppercase, doesn't matter. Okay, I gave uppercase. Okay, now next one. Router B 10, 20, 10, 10, 20, 1. Add. And then this router, I would like to call it as router C. Router C is any one of the address. You can give 10, 10, 10, 2 or 10, 10, 10, 22. I would like to give 10, 10, 22, another network. Done. We have added, and I own the DNS server now. So DNS service is running. This is a, how do we call it, a directory. In olden days, when I was small boy, very rarely will see phone. Not every homes were having phone. Getting a telephone connection is very difficult in those days. You need to apply and wait for years. I'm not joking, years to get a phone connection. And we used to have a yellow page book. Very big book, thick book. And that you will have all phone numbers and their address. Very detailed. Phone number with address. Today no one will dare to publish one book like that, phone number with address. But on those days we had everyone's address, phone number, name. So if you know a name of a person, you will know the address of a person. Sorry, if you know the name and the phone number, you will know the address. Or at least if you have phone number, that is enough to know the name and the address. If you search with the name, there will be many person with the name J. But if you search with phone number, then it is only one J. So here we are going to get the address of the device by typing RA. RA is equal to www.yahoo.com. Okay. I would have said ra.com. I don't want to make things complicated. Let it be simple RA. All right. Now what is next? The server is ready to serve, but the clients are not yet configured as a client. Let us first of all give IP address to these devices and ping between these devices. Okay, so I'll go to this router. First, I give the IP address. Host name R1, and then interface G. Bring it up by typing no shutdown, and give an IP address. IP address is 10.10.10.1. Mask is 255.255.255.0. Next, R3 I would like to finish. Interface G000. I bring the interface up and I put the IP address 10.10.21. This is what we have here, 10.10.21. All right. Host name is router 3. Next. The middle router. See, we have named this router as R1, but the domain name for this is RA. For this is RB. And for this is RC. According to the DNS. Now, on this router, interface G00 is 10.10.10.2. Next, host name is router 2. There's another interface G001. Yeah. 10.10.22 given. Now, listen to my question and answer. Try to answer. If I ping from A, will I be able to ping B? Answer is no. You know why? Because A do not know about this network. A has got no idea about this network 10.10.20. A is only connected to 10.10.10. Likewise, this also cannot ping that because this router do not have any idea about 10.10.10 network. So what to do? There is no communication between these two because they don't know route. We need to write route. You need to tell this router if the destination is 10, 10, 20. If this is the network that you want to go, send the packet to this guy, your router, 10, 10, 10, 2. This guy knows about 10, 10, 10, 20. He can forward. Likewise, on this router, we should say, if you wish to send any traffic to 10, 10, 10, 0, send the packet to your gateway, this guy. So this is equal to writing a default gateway in the computers. In the computers, we used to write default gateway. On the routers, we write static route. We call it a static route. Static. So we need to provide reachability. Only then we can test DNS. First, let us provide reachability. They all should ping each other. As of now, if you go here and ping this, it will ping. Ping this, it will ping. Ping this, it will ping. Because it is in the middle now, it can reach both. But what won't happen is this pinging this is not possible. Because this guy do not know the route. That's why we write a route. After you write this route and this route, A can forward the packet to C in order to go to B. C will forward it to B and vice versa. So what I'm going to write is called static route. How to write this? See, there is a separate topic for static route. I'll be teaching later. But now to do this lab, I'm trying to help you by teaching this in a short way. It is easy, you see. This is what we need to write. Because this router A do not know. Let me show you. Router A has got no idea about 10, 10, 20. Show IP route. You see, it knows only about 10, 10, 10. So if any packet needs to go to 10, 10, 20, it cannot go. If it wants to go to router 2, the network is 10. Sorry, if it wants to go to router 3, router 3's network is 10, 10, 10, 20.1. So this is how I write a route, IP route. You see, in the global configuration mode, in the configuration mode, that's why I call it as global configuration mode. Don't mind. Both are same, configuration mode or global. I've not taught you like global configuration mode earlier. I said configuration mode. Both are same. Okay, in the configuration mode, you need to tell IP route any traffic to 10, 10, 20 with this mask should be sent to the gateway 10, 10, 10, 2. This is router 2's address. Now let us check the routing table. Show IP route. You see, I have written a static route saying if any packet wants to go to the 10, 10, 20, it needs to go to 10, 10, 10, 2, which is this one. I'm asking to push the packet here. And this guy knows this location, so it can push. Likewise, on RB, I need to write a static route for this. Let's go to R2, which is also called as RB. I say IP route. If you want to send any packet to 10, 10, 10, 0 network, send the packet to 10, 10, 22. because this PC is in. Oh, I'm writing this in router 2. This is not the place to write. Where should I write? I should write on router 3. This is the router I should write. This router only don't have any idea about 10, 10, 10. So I say if you want to route IP packet to 10, 10, 10, 0 with this mask, just forward it to your LAN 10, 10, 22. That's all. Show IP route. You see, I have the route. Now, if I try pinging from here 10, 10, 10, 1, I should ping. You see, it's pinging. Just ignore this one. This is because of ARP. ARP was trying to learn MAC addresses in the path. You remember I was asking you how many times encapsulation will happen. Here, sender will send one encapsulation. Again, here it will remove and put another MAC address. Two encapsulation will happen and two decapsulation happens. I'm able to ping from this corner to that corner because of the static route I wrote. Our aim is not to check static route. Our aim is to do DNS. But for doing DNS, I need to have reachability between this and this. I'm already having it. I also want to make sure I'm able to ping this server. The server is the one to which I'm going to go and request the IP address for domain names. So, am I able to ping server? 10, 10, 10, 10. It is pinging. What about the other router? Am I able to ping? 10, 10, 10, 10. Yeah, it is pinging. Super. Now, what is next? We need to test DNS. But for that, these three routers should become a DNS client. Only then I can ping using the domain name. Listen, right now, how did I ping? I'm using if I want to ping router 3, I was pinging 10, 10, 21. I don't want to do like this. I want to ping like this. Ping router 3. Right now it won't ping because there is no DNS client. Server is there. To server, if someone says RB, sorry, not R3, RB. Oh, it's already pinging. But I did not configure this as a client. It is automatically, okay, you know what happened? This is very, very, it is doing broadcasts. That is how it was able to ping. That's not the way it should work. I don't want this to broadcast and learn. I want this to resolve the IP address of RB as 10, 10, 10, 10, 10, 21. Let me show you how to do that. IP domain lookup. This command is actually enabled by default. You no need to do this, but I just want to make sure that this is there. No one has disabled it. This is the important command. IP naming server. Which one is the naming server here? 10, 10, 10, 10. By doing this, I'm telling the router, that if this want to know the IP address of any domain, you should go and ask this guy. Makes sense, I believe. I'll also go to router A and do the same. Router A, oh, in router A only I did it. I'll do it in router B. There is a name server in this location. Go and ask this guy for any domain name to IP. Also on this router. This command makes this router to be a DNS client. As I said, this command is optional. It is enabled by default already. IP domain. Look. All right. Now let us try. I'll go back to the previous computer where I was pinging. This time I'm going to say ping router. What's the name of this router? Router C. Instead of giving the IP address of router C, I'm saying ping router C. Look at this. It did not do broadcast. Earlier when I was pinging, it was flooding and discovering, then pinging. It was sending to a broadcast address. I repeat the same RB, you see what happens. Ping RB. See? It straight away learned the address, no broadcasting. How RB knows the IP address of RB? Because we have configured the DNS server. It went to the domain name server, learned it. Let me go to router 3 and try pinging RA. You see, it has learned from this domain server. Let me ping RB again. Yeah, so DNS works. Now, you remember the other day we were able to telnet. Did I taught you telnet? When I ping with a name, it goes to the DNS server and asks about who is this RA. And DNS server says RA means 10, 10, 10, 1. 10, 10, 10, 1. So it sent the ICMP echo request to 10, 10, 10, 1. And when I pinged RB, it went to the DNS server querying for 10, 10, 10. Querying for RB. It went to 10, 10, 10, 10, which is the server querying for RB. It said RB is nothing but 10, 10, 21. That's how the packet was sent to 21. And the ping happens. Like this. In the internet world, like RA, RB, RC, we have a lot of domains. Facebook.com, YouTube.com. And like this DNS server, we have a universal DNS server. And IP address of the universal DNS server is 8888. This is Google DNS server. So the entire world depends on DNS server to provide the IP address of domains. Then and there, whenever they want, they go query DNS server, learn the IP, using that IP, communicate with the remote destination. There is also one redundant server like 8.8.4.4, I believe. That's for that is secondary DNS server. See, when we assign an IP address to a computer, we not only give IP address, subnet mask, and gateway, we also need to give DNS. You see? Use the following DNS server address. If you are giving statically, you have to give preferred and alternate. We not only give IP address, subnet mask, and gateway, we also give DNS. But in my laptop, I get it dynamically configured, so I don't give. It gets configured dynamically. So the reason for giving DNS server in your laptop is to go online. To go online, internet connection alone is not enough. There is need for someone to resolve the web address, the domain names into IP address of the domain. Every device in the earth has got an IP address. The domain name and all is for our convenience. www.tnpc.whatever, www.indianrailway.whatever. Those things are for our convenience. Any question on DNS lab that we did? What we did first, we created a directory here. We said if someone is coming with RA, then for RA, give this address 10, 10, 10, 1. If someone is coming with RB, asking for RB, then give 10, 10, 20, 1. That's the IP address of RB. RA segment. And then we said if someone is coming with RC, then give this address 10, 10, 22. You can give this also, anyone. This has got 2 addresses. Now, this part is over. So let me show you that. You see, it was like this. I just click this. It'll be like this initially. You go here first, give the IP address 10, 10, 10, 10, mask, and then the gateway. Because it is in 10, 10, 10 network, first 3 octet is 10. So the gateway also first 3 octet should be 10, 10, 10, 10. And then click on services, DNS, add one by one the name and the address, and say add button. We add as many you want. This is over. That's the first step. Second step is go to all the routers interfaces. Give IP address. This is the IP address of this port, G000. This is the IP address of this port. This is the IP address of G000. This is the IP address of this port. Next, if I need to ping from here to here, if I want to say ping RB, I need reachability. And I need DNS support. DNS is ready, but where is the reachability? No reachability. Because RA don't have root. RA don't have root for this network 20, 10, 10, 10, 20. So what we did is we wrote static route. This is the syntax. This is the way. R1 do not know about, R1 knows only about 10.10.10. They don't know about 10.10.20, so we wrote IP route. If you want to go to 10.10.20, go to this next router. That's our router 2's address. What happened? Show IP route. We wrote this one. Similarly, on router 3, this router 3 is router B. In router B, we wrote this route. In order to go to 10.10.10, you should go to 10.10.22. Basically, we are saying B to go to this address. Earlier, we went to router A and said go to this address to go to 10.10.10.20. Here we are going to say in order to go to 10.10.10.10, go here. This is static route. Do you have any question up to this one, the static route? Have any question up to static route? For both? Okay. Next step is simple step. Only one command you are typing, telling the location of DNS server. See, if you don't tell the location of DNS server, if you don't tell this location of DNS server, how router 1 will send the DNS request? When you type ping RB, the request should go to the server. So these routers should know that I have a server to go. Like we used to go to Google DNS server 8.8.8.8. In our scenario, instead of 8.8.8.8, we have 10.10.10.10. So that is what I configured on all the router. Just this one line. This line is automatic. It is already there. But sometime, in the real world, some people may disable this command. That's why you need to first enable saying if someone types a domain name like Google, router B, RB, RC, you need to look into DNS. That's the meaning. And this is the DNS server address. Put these two lines, or at least this line which I highlighted, after which when you try pinging with a domain name instead of IP address, RC, it automatically resolves the IP address of RC with the help of this DNS server. It went straight to the DNS server because I mentioned the address of the DNS server here. That's all we did. Any question?